Hello everyone, and we're on the next question now. This is question 4, and this is a question on hypothesis testing. Okay, so it says the proportion of left-handed adults in a country is 10%. Freya believes that the proportion of left-handed adults under the age of 25 in this country is different to 10%. She takes a random sample of 10 adults under the age of 25 from this country to investigate her belief. Find the critical region for a suitable test to assess Freya's belief. You should state your hypothesis clearly, use a 5% level of significance, and state the probability of rejection in each tail, 4 marks. Okay, so step 1 then, let's write down our null and our alternative hypothesis. So the null hypothesis is that the probability of being left-handed is 0.1. And our alternative hypothesis is that it's going to be not equal to 0.1 because Freya believes it's different. We've got a binomial distribution, and in the sample there are 40 people, 40 adults. It's a binomial distribution because the results are independent, there's a fixed probability, a fixed number of trials, and the probability doesn't change. So I've just drawn a distribution here. And don't worry if you're not used to seeing that from year 12. This is just like a normal distribution. And we're trying to find the 2 critical regions at either end of the distribution. So let's consider over here at the left-hand side. And I've written C1 for critical region 1. So just going to basically try a whole different bunch of values and see when we get to a significance level that is below 0.0, a probability that's below 0.025. Now notice I've halved the significance level, okay? It's 5% for the test, but because we've got a 2-tail test, we're going to be comparing it with 0.025. So first of all, I've worked out the probability of x is less than or equal to 0 on my calculator using the binomial CD. That gave me 0.01478. Now that would be inside the critical region. So we need to have 1 above and 1 below so we know where the boundary begins, okay? So now I've tried x is less than or equal to 1. And that gives me 0.0847, which is bigger than the critical value. So the first value that's inside the critical region is going to be this 0.01478. So that's where our critical region is going to start on the left-hand tail. Okay, so it's going to be x is equal to 0 is our critical region on the left-hand side of the tail. Now let's have a look at the right-hand side of the tail. So if you want to know, what value should I pick, the expected value is n times p. So n in this case is 40 and the probability is 0.1. So n times p is going to be 40 times 0.1, so 4. So I should pick values that are bigger than 4 over on the right-hand side of the distribution. So I've just picked 7. So I've said probability of x is greater than or equal to 7. Now again, depending on the calculator you use, you could just select the right-hand tail. But if you're using a non-graphical calculator, you can do 1 minus the probability of x is less than 0.06. So that gives me 0.1. And this is way bigger than my 0.025. So I'm going to try and say, jump up a little bit and say, okay, let's try 9. So probability of x is greater than or equal to 9 is 1 take away the probability of x is less than or equal to 8, which gives me 1 take away 0.945. That is 0.0155. Now that's less than my 0.025. So now I need to say, okay, 9 is definitely less than the region, the value that we need. So let's try 8, because remember I want 1 above and 1 below, so I can decide where my critical region is. So I try 8 and I get probability of x is greater than or equal to 8 is 1 take away 7. The probability of x is less than or equal to 7 is 0.958. And that gives me 0.0419, which is bigger than my 0.025. So the first value that is less than 0.025 is x is greater than or equal to 9. So that's where my critical region is going to start at the other end of the distribution. Okay, so you've got 0 and greater than or equal to 9. So the critical region for this test is either x equals 0 or x is greater than or equal to 9. Okay, part B. Write down the actual significance level. Now, when they say the actual significance level, what they want you to do is write down the 2 probabilities that correspond to the critical values. In this case, our 0.01478 and our probability here for the greater than or equal to 9. So the actual significance level, you just write down the probabilities that are associated with your two critical values and add them together. And that gives us 0.0300303. So that's part B done. And then finally, for this question, it says, in Freya's sample, 7 adults were left-handed. With reference to your answer in part A, comment on Freya's belief. So we found that the critical region was 0 or greater than or equal to 9. Freya's found that there's 7 of them. So 7 is not greater than or equal to 9, so we're not in the critical region. So 7 is not in the critical region, so therefore there is not enough evidence to reject HO. In other words, there is insufficient evidence to support Freya's belief. Quite a nice, really nice, straightforward binomial hypothesis test there. I hope that you found that helpful, and I'll see you in the next video.